Hello, we are now starting chapter 11, which is the last section in our course. This is about sequences, series, and power series. So what is a sequence? In mathematics, we say a sequence is a list of numbers. Now, when we talk about a sequence, we actually mean an infinite sequence, which means a list of infinite numbers, or an infinite list of numbers. And if the list is consists of finite numbers, we will call it finite sequence. Now, when we are given the list like A1, A2 is, and this is how we will be denoting the numbers on the list, or we also call them terms of the sequence. The A1 is called the first term, and then the next one is the second and third, and so on. A notation for a sequence is just to write them like a list, like here, or you can put them in, inside these brackets, the braces, or even we can have a situation where we are using these compact notation for the sequence. So whenever you see A sub n or B sub n or some other letter sub n and inside braces, it means it's a sequence. And sometimes then we are also putting the limits on the n. N can start basically from anywhere, but in usual it will start at 1. So for examples of some sequences can be seen down here, and sometimes we can actually define a sequence by giving an nth formula for the nth term. So the nth term is called a general term of the sequence, and a formula given for the nth term actually helps us see the terms of the sequence quickly. So here is the first example. So the sequence is 1 over 3 to the n, which means the an is 1 over 3 to the n. So if you want to find a1, it means it's 1 over 3 to the 1, which is 1 over 3. And then a2 will be 1 over 3 to the 2, which means 1 over 9, and so on. So you can list, however many initial terms of the sequence you want to list. So second example here, and so in the first case, you can notice here no limits are given here. So we will start with n is equal to 1. Now this one could start at n is equal to 0, n is equal to -1, n is equal to -2, or some other number. Second example is where we are starting at n is equal to 2. So when n is equal to 2, you notice the first the first term will be when you plug n equal to 2. So a1 in this case will be 2 over 2 plus 1, which means 2 over 3. And a2 will be 2. So for a2 n will become 3. So you get 3 over 4 and so on. So a1 is 2 over 3. A2 is 3 over 4, A3 will be 4 over 5, and so on. Now if the same sequence had started from n is equal to 1, then the first term would have been 1 over 2, and the rest of the terms would be the same. Looking at part C here, so notice that now we have a -1 raised to the power n in front of the expression. So this -1 to the n is actually included in our a sub n. So our a sub n is -1 to the n plus 1 whole divided by 3 to the n. And the n starts at 0. So the first term will be a sub 0, so which will be -1 raised to 0, 0 plus 1, which is 1, over 3 raised to the power 0. But 3 raised to the power 0 is 1, -1 raised to 0 is 1, so the first term is 1. which is what I have here written as 1 over 1, but you can easily write it as just 1. So a1 will be negative 1 to the 1, 1 plus 1 over 3 to the 1. So you get negative 2/3, which is the second term here, and so on. So notice here we are getting alternate signs. So the first term is positive, second is negative, third is positive, fourth is negative, fifth will be positive, and so on. So sometimes we have we call such a sequence alternate sequence. So we are having alternate signs. So in this example, we saw that we had the nth term was given, and we were able to expand and write our terms of the sequence. Now sometimes you will be given a sequence or a list, and you will have to find the nth term on your own. You have to just basically observe and then should be able to figure out what the a sub n is. So in this case, for example, you can see that a1 is 3 over 5, a2 is minus 4 over 25, and a3 is 5 over 125, and so on. So one thing is for sure that this is alternating. So when you write your a sub n, so one thing is that there will be a negative 1 raised to. Now you have to decide how you are going to put that the power up there so that the first term is positive, second is negative, third is positive, and so on. So if you just put n here, then you will see that you do not get the first term as positive because we are starting at n is equal to 1. So in order to make it, you can either say n minus 1 or you can say n plus 1. And then what is happening, when n is 1, your top is 3. When n is 2, your top is 4. When n is 3, your top is 5. So which means the top is n plus 2. And at the bottom, you can see these are powers of 5. So you can say 5 to the n. So that is your nth term or the general term for this first sequence. For the second sequence, you can easily see a1 is square root of 3, a2 is square root of 4, and so on. So that it gives us the idea that the a sub n is square root of n plus 2. Okay, looking at the next one, so first one is a1 is equal to 3, a2 is negative 5, a3 is 7, and so on. a4 is negative 9, a5 is 11. So what do you notice here? If you are able to see what type of numbers are we dealing with. So these are odd numbers. And then we have the alternating thing. So for sure there is a negative 1 raised to. So if your first first term is going to be n is equal to 1, at n is equal to 1, then we need to have again n minus 1 or n plus 1 on the top so that our first term is positive. And then we have to write something, a formula which gives us those odd numbers. And if you recall from somewhere before, an odd number is expressed as 2n plus 1, a list of odd numbers, and 2n plus 1, where when n is 1, you get 3, when n is 2, you get 5, when n is 4, when n is 2, you get 5, when n is 3, you get 7, and so on. So this is your a sub n. The next thing we want to see is limit of a sequence. So how do we find the limit of a sequence? So basically, the limit of a sequence is the limit of the general term. And we say that a limit of the sequence is equal to L if the limit of the term a sub n, or the limit of the general term as n goes to infinity, is equal to L. And this will happen when these terms get very, very close to a number L, and as we are moving towards infinity, as n moves towards infinity. So if the limit exists, we say and is equal to finite number, we say that the sequence converges or the sequence is convergent. And if the limit does not exist, or you get this limit equal to infinity or minus infinity, we say that the sequence is divergent. So either the limit does not exist or the limit is positive or negative infinity. In both cases, we say the sequence is divergent. And if the limit is a finite number, then we say the sequence is convergent. So let us look at whether the sequence is converging or diverging. So the first thing you need to figure out is what is a sub n. So in this case, a sub n is 1 over 3 to the n. So limit as n goes to infinity of 1 over 3 to the n, you can see is 0. So it's a finite number, so which means sequence converges. Okay. So part B, so a sub n is 4n squared minus 3n over 2n squared plus 1. So what we need to do is find the limit as n goes to infinity of a sub n, which means limit as n goes to infinity of 4n squared minus 3n over 2n squared plus 1. So how do we find the limit of something like this? Well, you can use the L'Hopital rule, yes, but there is a simpler way to do it, and that is by dividing the top and bottom by the highest power variable. I would suggest in the denominator, but it's your choice. You can divide by the highest term variable, whether it is in the numerator or in the denominator. So in this case, because the highest term variable is n squared, so it is same, so we will divide the top and the bottom by n squared. So we end up getting 4 minus 3 over n, and at the bottom 2 plus 1 over n squared. Now we can apply the limit to each of these terms, especially the terms with the n. The other ones don't change, they just give us back the number. So I don't need to write this thing in front of those numbers, which if you write, it's not wrong. And so now this limit is going to go to 0. This is something that you have to remember from Calc 1. And this goes to 0. And the reason is that limit of 1 over n raised to the power r when n goes to infinity is equal to 0 if r is greater than 1. Actually, when r is greater than 0, it will work. Okay, so now we end up getting 4 minus 0 over 2 plus 0, which means 4 over 2 or 2. So we are getting a definite number, so we say it converges. So the sequence converges. Looking at this one, the an is n to the 4 over n cubed minus 2n. So we do the same thing, limit as n goes to infinity of n to the 4 over n cubed minus 2n. And as I said before, I am going to divide by the highest power in the denominator, which means n cubed. So when I do that, on the top I am getting n. At the bottom we get 1 minus 2 over n squared. And when I apply the limit to wherever the n is, so this gives us infinity over 1 minus 0 or infinity. So this case, the sequence diverges. Okay, looking at this next one, it's not, like we cannot look at the limit directly. So for example, if I say limit of minus 1 raised to the power n as n goes to infinity, well, this is actually not a single value that we will get, but depending on what n is, whether even or odd, we will get 1 or minus 1. So let's list some values over here. So when n is 1, we get negative 1, n is 2, we get 1, then negative 1, then 1, negative 1, 1, and so on. So which means there is no fixed limit. We are basically going to get either 1 or minus 1, and so the limit does not exist. So therefore diverges. Okay, looking at this next one, where in this sequence again we are given the nth term already, so we will be finding limit as n goes to infinity of n squared e to the minus n. So if you recall, this is something from Calc 1 that we can find this limit by using the L'Hopital rule. So can write it as limit n squared over e to the n. So now in this case it is infinity over infinity form. So by LH rule, we get limit as n goes to infinity of 2n over e to the n. This is already in the simplified form. We cannot simplify further. But if I plug in, you notice it's still infinity over infinity form. So we again apply LH rule. So we get limit as n goes to infinity of 2 over e to the n. And now when we apply the limit, we actually get 0. So which means this converges. Okay, looking at the next one, well, here again we have a negative 1, so it's an alternating series. But if you try to write some of the values here, so if you try to write the sequence actually, so what are the values of the sequence? So when n is 1, we can start with 1. When n is 1, we end up getting negative 1 over 2. When n is 2, so we are getting positive 8 over 9. And then negative, so when n is 3, we are getting negative 27 over 28, and so on. Okay, so we are getting alternating these numbers, so alternating sequence. But notice here that the numbers are now decreasing. So if you look at the value of each number, so the first one is 1/2, and the next is 8 over 9, then 27 over 28. If you look at the value of each number, they are decreasing. So in this case, what we do, we try to find the limit of the positive sequence. So we will try to find the limit of the absolute value of it. So what does the absolute value do? It actually lets us consume the negative sign. So now we are basically looking at just n cube over n cube plus 1. Okay. So what is happening now when we try to find this will give us that the limit is 1 like before, because we will divide by n cube. So we end up getting, so limit is 1. So, but this is for the alternate, the absolute. So which is telling us that either we are going to get the value -1 or 1. So we say the limit does not exist. Limit of an as n goes to infinity does not exist. So diverges. So this is how we find whether the sequence diverges or converges.